Hey guys, today we're doing compound inequalities. So compound inequalities are when you have two inequalities that are joined together by the word and or the word or. Those are the only two words that we use. I'm going to refer to them as our joining words. When you see a compound inequality with the word and, that means that both individual inequalities must be true at the same time. Or is going to mean that either one may be true or both of them might be true. So some examples that you're going to see: x is greater than 2 and x is less than -3. We also have x is greater than 3 or x is less than or equal to -2. We're going to practice graphing them today on a number line. So let's take a look at that. For our first example problem, we're going to do x is greater than 2 or x is less than 0. When we graph these, or statement means we want all of our answers or all of our solutions. What that's going to look like on a number line, we are going to graph the first inequality all by itself, and then we'll do the second one. So let's start with x is greater than 2. I know that I have a point at 2. It's open because there is no line under the symbol. And it says x is greater than 2, so it's going to point off to the right where all of the larger numbers are. Then we have x is less than 0. So I'm going to have a point at 0. It's open because there's no line. And then this is going to point to the left. So this graph represents all of the solutions that are either bigger than 2 or smaller than 0. So that's why we want all of our solutions, because 3 would satisfy that compound inequality, -5 would satisfy it, but 1 would not. Okay, let's look at another example. I'm going to pick a different color here. So for number 2, we have x is greater than or equal to 1 and x is less than 5. So for these, an and statement means that we need to have both of them be true. So let's do the same thing where we're going to graph one at a time, and then we'll look at what's happening. So x is greater than or equal to 1. I've got a point at 1. I'm going to put this one above my graph, and I'll show you why in a minute. So we've got a point at 1. It does have a closed circle because there's that line there. And then it's going to point to the right. Now for my second one, it says x is less than 5. So I have a point at 5. I'm going to put it up here. So 5 is going to be right about here. And then that is going to point to the left. So on the graph, there is one section where both of these inequalities are true at exactly the same time. And that's where these guys are overlapping. So we can see that they overlap between these 2 points. So I have one more step here to graph my final solution. Now I'm going to actually write it down here underneath the box that I made. I have a solid point at 1. I have an open point at 5, and my line connects them in the middle because that's where they overlap. I'm going to write it down here too, just so that you can see it a little bit clearer, because I feel like there are a lot of lines there. That is my final solution, because that is where these two inequalities overlap. That's where they're both true at the same time. Okay, I'm going to go over a couple of special cases with you before we do our practice, because I just want you to see them so that you understand what's happening. So we've got 4 special cases. This doesn't necessarily mean it's all of them, but these are the ones you're going to see the most often. So for the first one, we have x is greater than 1 or x is less than 5. So I've got a point at 1, and it goes off to the right for x is greater than 1, and then it's x is less than 5, so that one goes here, and it goes to the left. But I do have that this is an OR. And OR means all. OR does not mean overlap. And because I'm looking for all of it, they do overlap in the middle, but they go in either direction forever. And I want all of my possible solutions. So in this case, all of my solutions happen to be the entire number line. So this is a situation where you have infinite solutions. Every single number that exists is a solution. You'll also hear that called all real numbers. Okay, let's look at this next one here. X is less than or equal to -3 or X is less than 4. So I'm gonna graph them again. X is less than or equal to, let's see, -3 is 1, 2, 3 here. I have a filled in circle pointing to the left. And then I have X is less than 4. So 4 is gonna be here. And then it is also pointing to the left. Again, because I'm dealing with OR, and OR means all solutions, that means I want every single part of this. So when you are dealing with OR, you want whichever line is the longest. So this is gonna be the longest line. Up here where they pointed in opposite directions, it's everything. Down here, because they overlapped, that was everything. But here where they're both pointing in the same direction, this longest line is going to represent all of my solutions because this shorter line is included in that line. So for this compound inequality, it's actually just representative of X is less than 4. So that's going to happen sometimes where you're going to have an OR and they're going to overlap. Okay, next one. I've got an AND statement here. So we have X is less than -4 and X is greater than 2. So let's graph those. We've got -4, open point, and pointing to the left. And then I have X is greater than 2. So I've got an open point at 2 pointing to the right. So the way I want you to think of that is there any way that you can have a number that is smaller than -4 and bigger than 2 at the same time? The other way you can think about it is that and is where your graphs overlap. And I think it's very obvious here that they do not overlap. They never overlap. So this is going to be no solutions. Okay, last one. This is the same starting graph as the one above it. So I have X is less than or equal to -3. So I've got a point here pointing to the left, and then I have a point at 4 that's open also pointing to the left. For this problem though, it's not all of our solutions, but it is where these guys overlap because it says and. So you can see that they overlap starting here at -3 and going to the left. So my final solution is going to be that filled in point at -3 and to the left, or X is less than or equal to -3. And that's just because both of the arrows are pointing in the exact same direction at the same time. And because this is and, I care about where they overlap. So I made these two problems the same to show you the difference when you have two inequalities pointing in the same direction, how OR is different from and in the solutions of these. And takes the shorter line, OR takes the longer line. Okay, let's do our guided practice together. I've got the 4 problems here, so let's take a look at them. If you haven't done them yet, I would encourage you to pause the video, go do them in your notebook, and then come back to check your answers. Okay, for number 1, I have X is greater than 3, so I have an open circle at 3, and that line goes to the right. And then I have x is less than -1, so I have an open point at -1. That one points to the left. And since or means all, that's my answer. That's it. I'm done. Okay, for number 2, x is greater than or equal to -1. So I have a closed point at -1, and my line points to the right. And then I have x is less than or equal to 2. So I have a closed point at 2, and my line goes to the left. This is an and statement, so and means overlap. So my answers fall between the closed point at -1 and the closed point at 2, because that is where the two lines overlap. Okay, number 3, x is less than 4. Open point at 4, and the line goes all the way to the left. And then x is less than -1, I have an open point at -1, and the line goes to the left as well. We just talked about what happens when the lines go in the same direction at the same time. We're going to take our longer line because it's or. So I have an open point at 4, and that line going all the way to the left. Okay, last one. X is greater than 3, so I have an open point at 3 going to the right. And then x is greater than or equal to 4, so I have a closed point at 4 and my line to the right. Again, it's going to be two lines heading in the same direction, but it's and now, so we're overlapping. So that's going to be the shorter line. Closed point at 4, line to the right.